Indexing is a key concept in managing large volume of data. The multi-level indexing is one of the smartest way to enhance performance in massive datasets. Let's start with a quick overview. As database grows in size, accessing data quickly becomes more challenging. Suppose we have millions of records. How do we avoid checking every single one? That's where indexing comes in. But even indexing can become a bottleneck when the index files themselves grow too large. Multi-level indexing is a technique that addresses this problem by adding layers to the index like a hierarchy, so we can access data in a fewer steps. What is an index in DBMS? Index in a DBMS in a database is like a lookup table. It helps us find data without scanning the whole database. Think about how a book works. Instead of reading every page, we go to the index, find the topic and page number, and jump straight to it. In database, an index stores the search key along with a pointer to the actual data record. This improves the speed of data retrieval significantly. Need for indexing. Why do we need indexing? Imagine a table with 10 million customer records. Without an index, a search query would have to scan every record. That's slow and inefficient. Efficient index help in reducing search time, avoiding full table scan, optimizing filtering and sorting operation. So indexing is essential not just for performance but also for scalability. Single level index. In single level index, we maintain a shorter list of a key pointer pairs. Each entry points to a block or a record in a data file. It's efficient up to point, but as the number of records increase, the index file becomes too large to handle quickly, especially if it can't fit into a memory. Every time you need to access a record, the system may have to go back and forth between disk and memory multiple times. Problems with single level indexing. The main issue with single level index are index size. As more data is added, the index size keep growing. Slower access. Searching within a large index is itself time consuming. Disk IO overloaded. Large index often don't fit into RAM, so we need more disk reads. Clearly, we need a better structure when dealing with large scale systems. Introduction to multi-level indexing. Multi-level indexing is the solution. It works by indexing the index. That is, creating multiple levels of index. Each level stores pointer to the next level. This creates a hierarchical structure that is far more efficient. You think of it like a tree. You start at the top, narrow down, you search through each level, and eventually reach the data. Structure of multi-level index. Let's break it down. The bottom level is the actual data block. The first level index those data blocks. The second level index the first level indexes the first level index, and so on. At each step, the amount of data being searched gets smaller. The top level index is tiny compared to the full dataset, and ideally, it can be kept in memory for instant access. Example of multi-level index. Imagine you are searching for a record. Start at the top level index, find the correct pointer to the second level index, follow it to the first level index. Finally, go to the data block. Even though this involves multiple steps, each step is faster because it searches a small set of entries. This reduces disk access and time and speed up overall retrieval. Condition for multi-level indexing. There are two key conditions for using multi-level indexing. Shorter index file, so we can use binary search at each level. Disk-based design. These indexes are particularly useful when the entry index cannot fit in the main memory. This is often the case in large-scale systems. Types of multi-level index. There are different ways to structure multi-level index. Dense index. Every search key has an entry. Spare index. Only one entry per block. We also have clustered index. The data is physically ordered based on the index. Unclustered index. The data remains unordered. These can be combined in a multi-level index depending on the use case. Next, dense versus spare multi-level index. Let's compare. A dense index gives faster search result but takes up more space. A spare index saves space but may require extra step to find the exact record. In practice, we often use a dense index at the lowest level, closest to the data, and spare index at the high level to balance speed and storage. Algorithm for search. Here's how search works. Start at the top index. Use binary search to find the pointer to the next index level. Repeat until you reach the data. This means fewer comparison and faster access, particularly when the index is too large to load entirely into RAM. Insert and delete operation. Inserting or deleting record in multi-level index is more complex. You may need to update not just the base level but also one or more index level. If this index becomes too full or too empty, you might need to split, merge, or reorganize parts of the index. This extra overhead is the trade of better search performance. Space complexity. Multi-level indexes do consume additional space, but much less than you might expect. Each level stores fewer entries than the level below. The top level is very small, often just a few blocks, since only small parts of the index are in the memory at a time. It is a space-efficient solution for large datasets. Next, time complexity. Time complexity is one of the biggest advantages. With n records and b entries per index block, you need only log base b of n steps to find a record. This is similar to the binary search and is far more efficient than scanning the full table. Advantages of multi-level index. Let's summarize the benefits. Fast search time, even in a very large dataset. Efficient use of disk I/O. Less data is read from disk. Scalability works well as data continues to grow. Layered structure allows small index to reside in memory. Disadvantage. Of course, there are some downsides. Insert and delete operations are more complicated. Index maintains become a task in itself, not ideal for small or infrequently update tables. Despite these, multi-level indexing is still a go-to method in large production systems. Application. You will find multi-level index in many real-world systems. relational database like a MySQL, PostgreSQL, file system for path lookups and database storage, data warehouse to manage petabytes of structured data efficiently. There are everywhere data performance matters. Comparison with the B plus T indexing. Finally, let's compare with B plus T. B plus trees are a specific type of multi-level index with a balanced structure. All data is at the leaf nodes. Internal nodes only store keys and pointers. They are ideal for systems with frequent insertion and deletion. So, if you need a dynamic balanced structure, B plus tree go to the implementation. Thank you.